The topic of this session is nth derivative of some standard functions. Sometimes some functions occurs frequently and whose nth derivative we require. For this purpose, we are taking some functions and we'll find their nth derivative. For example, the first is y is equal to ax plus b to the power m, and show that the nth derivative is factorial m divided by m minus n factorial a to the power n ax plus b to the power m minus n. So if y is equal to this, then the nth derivative will be this expression. Let us see how. Given y is equal to ax plus b to the power m. So finding the derivative with respect to x, we'll get y1 is equal to ma ax plus b to the power m minus 1. Finding the second derivative, so it is y2 m into m minus 1 a square ax plus b to the power m minus 2. Similarly, the third derivative will become y3 m minus 1 m minus 2 a cube ax plus b to the power m minus 3. In general, following this, we can write yn as a m minus 1, m minus 2 up to m minus n minus 1 a to the power n ax plus b to the power m minus n. Because here y3 becomes m minus 1, m minus 2 a cube ax plus b to the power m minus 3. Similarly, this yn becomes m minus 1, m minus 2 up to m minus n minus 1 a to the power n and ax plus b to the power m minus n, which can be written as further yn is equal to m minus 1, m minus 2 and so on m minus n plus 1 a to the power n ax plus b to the power m minus n. Remark: if m is positive integer, then above equation can be written as yn is equal to factorial m divided by m minus n factorial a to the power n ax plus b to the power m minus n. Now let us take this second example. Here y is equal to 1 upon ax plus b, and show that yn is equal to minus 1 to the power n factorial n a to the power n ax plus b to the power n plus 1. That is, y is equal to 1 upon ax plus b, then nth derivative is given by this expression. Let us see how. Y is equal to 1 upon ax plus b. This implies y is equal to ax plus b to the power minus 1. Finding the first derivative with respect to x, it gives y1 is equal to minus 1 ax plus b to the power minus 2, and further derivative of ax plus b gives the value, this value a. Similarly, if taking the second derivative, we get y2 is equal to minus 1 minus 2 a to the power 2 ax plus b to the power minus 3. Now just see the pattern. y3 becomes minus 1 minus 2 minus 3 a cube ax plus b to the power minus 4. So following this, we can write the nth term, nth derivative as a minus 1 minus 2 up to minus n a to the power n. Just see the correspondence, ax plus b to the power minus n plus 1, which can be written as minus 1 to the power n factorial n a to the power n divided by ax plus b to the power n plus 1. Now let us take this example. If y is equal to log ax plus b, then show that yn is equal to minus 1 to the power n minus 1 factorial a to the power n divided by ax plus b to the power n. Let us see the solution. Given y is equal to log ax plus b, so finding the first derivative, y1 will become 1 upon ax plus b into a. This can be written as y1 is equal to a into ax plus b to the power minus 1. Now finding second derivative, it becomes minus 1 ax plus b to the power minus 2, and the further derivative of ax plus b gives a, and this a will become a square. Similarly, y3 becomes minus 1 into minus 2 a cube ax plus b to the power minus 3. Observe this pattern. Following this, we can write in general the nth derivative as minus 1 into minus 2 and so on up to minus n minus 1 a to the power n ax plus b to the power minus n, which can be written as minus 1 to the power n minus 1, n minus 1 factorial, a to the power n divided by ax plus b to the power n. Now let us take this example in which if y is equal to a to the power mx, then show that nth derivative is given by m to the power n, a to the power mx into log a to the power n. Let us see the solution. Y is equal to a to the power mx. This gives y1, that is first derivative is m times a to the power mx into log a. Now finding the second derivative, it gives m square a to the power mx, and again the derivative of a to the power mx is log a. So log a into log a becomes log a square. In general, by following this, we can write yn as m to the power n a to the power mx log a to the power n. Now if y is equal to e to the power mx, then show that nth derivative is m to the power n e to the power mx. Solution. Put a is equal to e in the above result and use log e is equal to 1. Now let us take this example. If y is equal to sine ax plus b, then show that yn is equal to a to the power n sine ax plus b plus n pi by 2. Let us see the solution. We use the formula sine pi by 2 plus theta is equal to cos theta in finding the nth derivative. We have y is equal to sine ax plus b. Finding first derivative, it gives y1 is equal to a cos ax plus b, because derivative of sine ax plus b is cos ax plus b, and further derivative of x plus b is a, so this a is appearing over here. This can be written as, using this formula, cos theta becomes sine pi by 2 plus theta. It can be written as a times sine ax plus b plus pi by 2. Now finding the derivative, the second derivative y2, the derivative of sine ax plus b plus pi by 2 is cos ax plus b plus pi by 2. And further derivative of ax plus b gives a. So this a, so it becomes a square. Now again, cos theta is sine pi by 2 plus theta. So this can be written as a square sine ax plus b plus 2 pi by 2. Now finding the third derivative, it becomes a cube cos ax plus b plus 2 pi by 2, and again using this formula, this can be written as a cube sine ax plus b plus 3 pi by 2. So see the pattern, y1 becomes a sine ax plus b plus pi by 2, y2 becomes a square sine ax plus b plus 2 pi by 2, y3 becomes a cube sine ax plus b plus 3 pi by 2. So in general, we can find yn as a to the power n sine ax plus b plus n pi by 2. Now let us take this example in which y is equal to cos ax plus b, then show that yn is equal to a to the power n cos ax plus b plus n pi by 2. Let us see the solution. For solution, we use the following formulas. First, sine pi by 2 plus theta is cos theta, and cos pi by 2 plus theta is minus sine theta. So we have y is equal to cos ax plus b. The first derivative y1 becomes, the derivative of cos x is minus sine x. So it becomes minus sine ax plus b, and further derivative ax plus b becomes a. So this expression is minus a sine ax plus b. Now using the formula minus sine theta become cos pi by 2 plus theta, we can write this as a cos ax plus b plus pi by 2. Again finding the derivative, that is second derivative, from this expression we get minus a square sine ax plus b plus pi by 2. Again using this formula, this can be written as a square cos ax plus b plus 2 pi by 2. Now finding the third derivative, we'll get minus a cube sine ax plus b plus 2 pi by 2. And using this formula again, we get a cube cos ax plus b plus 3 pi by 2. Now see the pattern. y1 becomes a cos ax plus b plus pi by 2. y2 becomes a square cos ax plus b plus 2 pi by 2. y3 becomes a cube plus a cube cos ax plus b plus 3 pi by 2. So in general, yn becomes a to the power n cos ax plus b plus n pi by 2. Now let us take this example. If y is equal to e to the power x sine bx plus c, then show that yn is equal to r to the power n e to the power x sine bx plus c plus n phi, where r is equal to root a square plus b square and phi is equal to tan inverse b by a. Let us see the solution. Given y is equal to e to the power x sine bx plus c, this can be written as finding first derivative. It becomes a e to the power x sine bx plus c, that is finding derivative of e to the power x gives this, plus e to the power x as it is, and finding derivative of sine bx plus c gives cos bx plus c, and further derivative of bx plus c is b. So this expression can be written as e to the power x, taking this common, a sine bx plus c plus b cos bx plus c. Now let a is equal to r cos phi and b is equal to r sin phi, where r is equal to under root a square plus b square and phi is equal to tan inverse b by a. So this y1 can be written as e to the power x r sin bx plus c cos phi, because we have replaced this a by r cos phi, plus this b is replaced with r sin phi, so this become r cos x plus b sin phi. Now from here, taking r common and using the formula sin x cos y plus cos x sin y becomes sin x plus y, we can write this as a y1 is equal to r e to the power x sin bx plus c plus phi. Note that y1 is obtained by multiplying y by constant r and increasing bx plus c by phi. We can see y is equal to e to the power x sin bx plus c. So y1 is r times e to the power x and sin bx plus c plus phi. Hence, we can write in similar pattern y2 is r square e to the power x sin bx plus c plus phi, that is 2 phi. In general, yn becomes r to the power n e to the power x sin bx plus c plus n phi, where r is equal to under root a square plus b square and phi is tan inverse b by a. Similarly, as above, we can prove that if y is equal to e to the power ax cos bx plus c, then yn is r to the power n e to the power ax cos bx plus c plus n phi, where r is equal to under root a square plus b square and phi is equal to tan inverse b by a. Thank you.